Hello. Let me turn the light on. Yeah. Hey, Revo. End of the day. This one's probably going to be quicker than this morning. We went for like an hour this morning, so if you missed that, then definitely go check it out. I also realized that 8 o'clock is exactly the same time as the embedded working group meetings. So in future episodes or future streams, probably not going to, I'll either skip Tuesdays or I'll pick a different time for Tuesdays. So I'm also going to kind of be keeping an eye on that. But yeah, let me see if folks jump into chat. Hey, Anatol, how you doing? It's been a day. Didn't get a ton done. Got some pretty diagrams drawn. Let's see. Today, yeah, the goal was to kind of write up what you can do today and what you can't do today. So I'll just run down those real quick. Like I said, I'm going to stick around for at least 15 minutes. Ideally, I'd like to run at 15 minutes because, yeah, I got some other stuff to do. Let me move this out of my way. Yeah, so this is things you can do in Ergot today. So trying to make like a picture of this, and I'm going to go back and write up some like pros for all of these. So it kind of turned into sort of like a feature overview. I don't know, like some of the, it's interesting how many different perspectives you need to kind of like document about what something does, of like how the insides work, and then like, oh, can I do this, or will it work for this kind of topology? So like I kind of broke this down into two sections. One was like a connectivity overview, or like a topology overview of like, hey, if you're building a system that looks like this, yes, you can use it for that. Or in the future, hopefully you can use it for that. And then the other aspect is like socket features. Like sockets are kind of like the main interface that you deal with. So like what they can do today, or what you can do with sockets today, or what you can't do with sockets today. So like, yeah, I can go over those real quick. Again, if folks have questions in chat, let me know. Otherwise, let me check discussions. We did have some cool feedback from the discussion this morning about Plan 9 or Wayland as comparisons. Anatol says topology is exactly what Anatol cares about, so that's awesome. So yeah, if you have questions, feel free to throw them in the discussions, throw them in chat. If you're here now, if you're watching later, hello, welcome from the past. Yeah. So like the simplest one is just, hey, I have a device that's connected to a computer. Like I do this a bunch for when you went logging, or when you want to be able to send like instrumentation commands. Like even if normally your device is just chilling by itself, being able to send it commands like, hey, I'm especially during development, being able to be like, hey, spin the motor like this, or hey, read the sensors and tell you what you read. Sometimes I have devices where like this is their whole life, is just being tethered to a PC, and they're like just like the real world extension of a PC, like spinning motors or reading sensors or whatever. Sometimes this is just for like development and stuff like that, where you want to be able to pull logs, or you want to be able to like do firmware updates or change config or things like that. And really, like, I don't know if I want to combine these or not, because like this is like a very specific thing that a lot of people do, and sometimes you have to like, it doesn't matter how the program implements it, it's how people think about the system. Like, because if I just have this diagram, even though this is exactly the same in Ergot, some people will be like, oh, well, I don't have 3 devices, I only have 1 device. And I don't know, sometimes it's worth saying that you can do this. Like, this is a reasonable thing to do with Ergot too. Because you might have multiple sockets or whatever over a single connection and things like that. Again, yeah, you can do the same thing. This is something that works today, where you can run one server and you can have multiple devices, either over USB or UARTs and things like that, and connect to all of them, and then actually connect them to each other. So if you want one microcontroller to talk to another one, they can kind of route messages through the PC and stuff like that. Also, let me know if the music is too loud or anything like that. That totally works. And it's worth noting that I do already have a version of this for TCP. So the idea is to use this I use this for testing, where you can have multiple consoles open, and they can all talk to one server, and they can talk to each other through this kind of like central hub and spoke topology. Anatol has written a bunch of stuff, so let me read that. Since receiving my latest batch of random sorted AliExpress toys, I've been thinking about it'd be fun to have a mesh of CUs that could do stuff independent of a PC that controls coordinate stuff, roughly separated into a control PCB, which has stuff like buttons, rotary encoders, and a bunch of sensor and actuator boards, which are well connected by the control board. Finally, a display board that can serve as a data logging device. It's all pretty close to the Adafruit I2C daisy chain thing, whose name I forgot, but I2C is whatever. Something Ergot could be a nicer comms layer for it. Stemma was the name. Yeah. Yes. I don't know if you're using mesh colloquially or if you mean like very specifically a mesh. Right now, one thing that Ergot very definitely does not have is any kind of like mesh routing or like even intelligent vector or like routing vector type stuff to figure out like loops in network topology. So if you're just saying mesh colloquially, yes. If you mean like mesh in the wireless mesh, like we will have a self-assembling network of nodes that bridge to each other, probably not now or for a very long time. But if you just mean colloquially, like, hey, I'll have one kind of central device, and then if you're doing this by wires, then RS-45 is great for that, especially if you have longer distances than I2C. Thinking either Star or Daisy Chain. Yeah, that totally makes sense. Star, I mean, Daisy Chain and Star, maybe. Sometimes. I know. They both can be reasonable in different cases. We can chat about hardware some other time. But yeah, and yeah, wired then, I would probably just say RS-45, and yeah, do Daisy Chain. That's pretty easy. It depends on your total distance, but if you're talking like house scale distance of 10 meters, you can get away with a lot of poorly terminated RS-45 networks, especially if you're not trying to push it up to like 10 megabit or something like that. If you just want a healthy 1 megabit bus connection of up to 10 meters, you can get away with a lot of wiring crimes in that amount of time. And I definitely will end up writing some RS-45 stuff. I was gonna say for wireless, I do have some older demos for like ESB or enhanced shock burst, which is Nordic's like dumb packet radio. I haven't looked into ESP's ESP now, but I've heard cool things about it. But yeah, it's my hope is that basically if you send packets or bytes, then we can figure out how to get Ergot across it. My main question would revolve around Ergot auto discovery, routing, endpoint names, pub sub, that kind of stuff. So Postcard RPC had a bunch of service discovery stuff, and I plan to bring it back for Ergot. I'm not entirely sure how I'm going to do that yet. Postcard RPC had one big macro where you declared all of your types, which is very useful because then I could auto-generate an endpoint that was like, please give me all of those types, and it would just vomit them all back at you. The downside is this could sometimes be fairly large if you had a lot of types or they're very repetitive. I definitely want to have some kind of discovery. We'll get to this in connectivity later, but one of the things you can do right now is just broadcasting. Like I have the replacement in Ergot of Postcard RPC's topics do flooding broadcast. So basically you can pick a TTL, and if you send a message out here, it will go to everyone within so many hops of here. So you can do the very like ARP flooding type thing where you just shout about things. In the future, I hope the seed router, or kind of like the biggest, smartest device in the room, can have some kind of discovery service where it can say, hey, I've heard about all these devices. So instead of having everyone having to flood, you can, if there is a device, so like if you do have a PC there that can keep the entire routing table in its brain because it has a heap, you could just say, hey, are there anyone here who has a full picture? And if someone says yes, then you can just talk to them and ask them questions. And if the answer is no, or like that time's out, then you can send like flood requests, like who has this service with this name kind of thing. So yeah. Or yeah, just ask. So like protocols is one kind of thing, but you would say like who has an endpoint of these types with this name? tell this person. And that way you can just like listen to an incoming stream of messages and then broadcast like who has this. Very like ARP brain kind of thing. Dream would be that you could hook up additional boards to a daisy chain of stuff just works, at least for the sensor data logging display path. Yes. Newly connected boards is... Okay, so... The answer for hot plugging. I have an RS-45 project called Erdnuss, like peanut. And it's like it's for the RP2040. I actually have the boards that I designed it for. Hold on, let me grab those. I have them out because I was planning on eventually working on this. But this is an RS-45 like daisy chain type thing. Hopefully that's visible and not all glare. But these are RP2040s with RS-45, and the idea is exactly to daisy chain them. And I have some RP2040 embassy code that will do discovery of new devices. Oh, excuse me, Anatol. Erdnuss. No, if it was wireless, maybe it could be Erdnuss, but I don't know. I've had too much of a day to get teased on my German pronunciation right now. So, yeah, Erdnuss, exactly. So if you want to look, eventually I plan to forward port that to Ergot. But yeah, it's basically like you have one central device, like who's in charge, usually the one who's hooked up over USB. And it just does like time division multiplexing. So it just pings individual devices and they can all send a message back and forth. And then occasionally it'll send out a, hey, is there anyone new here who would like an address? And it can assign addresses and stuff like that. So once you have that, then they're on the network. Then you can do regular discovery. Like you can do flooding or service discovery and things like that. So yeah, I definitely think it's a thing that you could do. Flooding is flooding right now, which is not great, but I plan to figure out maybe some smarter way of doing that. But yeah. Yeah, more than happy to chat. The plan is to just steal that old Erdnuss code and port that into Ergot. So if you end up building hardware for that, let me know. I have a couple spare boards that you could probably borrow. Otherwise, you can just use whatever AliExpress off-the-shelf RS-45 stuff. And if it's RP2040 based, I can share my notes with you. Yeah, my suggestion just for framing is usually like what do I do in this? Because the RP2040 doesn't have read to idle. Like technically it does, but if you use it with DMA, it breaks for funny reasons. So I think I did line breaks. So like you'll send a message. If you look, this was like December, like 2 years ago. If you search for Erdnuss on my Blue Sky, I think there's probably some pictures if it doesn't predate Blue Sky. Maybe just have the router decide whether it needs to flood or not. Yeah, I mean, it's... Yeah, I mean, the question is always, like, the devices don't really know what the other devices are doing. So, like, on a shared medium like RS-45, you probably wouldn't flood, or, like, you wouldn't re-echo it on the same medium. But for something like this with TCP or UART, the obnoxious thing is if you're sending logs and you just want to flood them to the PC, they'll also get echoed back to microcontrollers, but I don't know. This is getting too deep into this problem. But yeah, so these are the stuff that works today. Oh, and also we do have an example of just direct microcontroller to microcontroller. Someone wanted like 2 microcontrollers on the same board hooked up over a UART, and that works today. It's a little gross because I think they both hard code their addresses, but it's fine for now. So that's like topology that does work today. And then soon TM, I'm hoping to be able to do bridging. So this would be your PC to a microcontroller. So this is closer to actually what you're talking about, Anatol, of like USB to some big microcontroller, and then UART, SPI, I2C, RS-45 or whatever to other devices. So this device, this needs a couple things. I need to like formalize this concept of a seed router, because when, let's say this device gets connected to USB, it says, okay, cool, what's my network ID here? And it'll get given it by the PC. And then it goes, cool, now I also need a network address for my downstream network. So that, you know, to make sure that that is unique across the entire network. So we need to sort of define how a bridge can ask for a network segment assignment and say like, hey, I'm going to use this for, I'm going to use, you know, network segment 5. Does anyone have a problem with that? Or can someone tell me what it should be? And then like keep that alive over time to make sure it doesn't fall out. So that's an option. And then, yeah, if there are any like further ones down there. And then I plan to have some examples of like a broadcast bus. So this is my like RS-45 or radio, how you could do addressing and time division multiplex. So again, this is going to be like stealing that old Air News project. And then something similar for mediums where it's not really like a bus like that. So like SPI, where you have a bunch of connections, but you're only like selecting one device at a time. And I2C is kind of the same thing. It's a shared medium, but you send an address, so everything only kind of selects one thing. There's really not like a lot of actual technical differences here. It's more like a how you think about it. But yeah, it'd be good to have some examples for these. Yeah, some questions. And yeah, it should work with no PC. Some of the stuff that I'm doing sort of assumes that, but eventually I do want to support like no PC or like, you know, all networks can be ad hoc networks. I don't think it's a deal breaker. I would just try and figure out how to handle this. So for all this stuff, I want to be able to have like a mini version that's like, well, it can't do everything, but it can do just enough for these dedicated setups. So strong maybe. I'm open to thoughts on that. If you feel like doing some designing, or figuring out how far we can push it before we actually need that. Revo saying, I'm assuming that the router requests are just normal requests. I'm not entirely sure what you mean, but yeah, I mean they're all devices. Yeah, okay. I think I know what you mean. Of like, hey, asking for an assignment. Yes. I need to sort of define what that protocol is. So probably what would happen would be when you go online, this device would maybe broadcast out like, hey, who is the seed router? Or who should I ask for assignments or something like that? And that might be like a topic flood message. And then they might get back hey, seed router is this device. And then it goes, great. Then I might make an endpoint request to that device that says, please assign me a segment ID that I can use for this. Yeah. So this is getting sort of into those socket features. Let's see, did I miss? No, that's everything. So socket features, what you can do now, these are basically two things that I've stolen from Postcard RPC. So you can do blind broadcast or flooded broadcast, where you just fire. Like you just send, like, here's a packet of this type, I'm sending it out, please send it to everyone. And you just kind of send it out to every device. If you're on like a shared bus like this, maybe you just send it out once. If you hit a device that has multiple hop or multiple interfaces, it will send it out its other interfaces until it hits the TTL limit, or until it runs out of interfaces. Like if this device only has one interface and it received it on this interface, it won't echo it back. That's kind of how it works right now. Is it's smart enough to never resend it back on the interface it came in on, and then it also decrements the TTL every hop until it hits 0, at which point it stops getting propagated. The other thing that I have right now is endpoints, and these are request response pairs, where you say I send a request of this type and I get a response back of some other type, and these are fully symmetrical. Like PC can make a request to the microcontroller and get a response, and a microcontroller can make a request to the PC and get a response. This has no retries or timeouts or anything like that. It's just, you know, happy path, or timeout or something like that, because that doesn't require, neither of these require stateful sockets. You don't have to have like a session with another device, because right now none of the things that I've built right now actually have sessions. I have more questions, so I'm going to finish this and then I can go answer questions. This is the other big thing that I want to have in the future is sessionful sockets. So this would be where sockets on either side know that they're part of a connection. So you'd have one device initiate a connection that says, hey, you want to be a sessionful socket? And it can say yes or no. And then these two devices can like send messages back and forth. And eventually if one of them drops off, or if there are too many unanswered messages, or they just time out, then you can tell that the session has been dropped. This is neat for things like exclusive access to items. Like if I say I want to be the only one controlling the motor, I can say I can initiate a session full socket for the motor, and if the device says, no, I already have one, go away, you know that it's busy. You know that if you stop getting messages, maybe you shut off the motor because you want to like have a disconnect or something like that. And I think this also is this is the first step towards having like reliable delivery, retries when things time out, higher quality of service type stuff. So I think this is sort of like the first step towards having a more like TCP style, like, hey, I send a request. If that packet just got corrupted, the user space doesn't need to do that, or doesn't need to like explicitly resend that, because the socket itself will resend that, or some code approximating a socket will do that. So yeah, this is the big pictures of what works right now, and I plan to kind of flesh out some of these diagrams of like a more, probably I'll just take all the things that I just said and turn that into text, and then put this in the docs somewhere of like high level picture of what can you do, what can't you do, or something like, or what can you do soon, hopefully. Reason I was asking, because it means that implementing a specialized router is also totally a thing a user can do. Yeah, I mean, all these components are things you can do. Routers are vague concepts right now. Really, router is just a profile. So we talked about profiles a little bit this morning. So you totally could, in Ergot, there is only one stack, and then what specializes you as like an edge device or a router is a profile. So, yes, that is totally a thing that you can do, that a user can do. Am I planning to also support CAN bus as a protocol? The G0 parts have CAN-FD, which is quite useful in certain situations. Using it as a custom NEC, not official CAN spec compliant. The answer is I'm open to it. I have no idea how CAN works. And I know some versions, I think specifically CAN-FD, the frames are relatively small, like 64 bytes or maybe even smaller for like CAN Classic versus CAN XL or whatever that it's called, where I think it's maybe like 1K frames or something like that. My headers aren't huge, but they are like a couple of bytes. You'll run out of 64-byte frames pretty soon. So you'll need to figure out how to do fragmentation yourself. But I'm open to it. If you have questions, please open up a discussion and we'll figure out how to like spec out transport over CAN-FD. I'm open to it. But the relatively small frames and things like that, but they seem problematic, and because I don't have any CAN hardware, I'm going to lean on you. But basically, I'm okay with Ergot being a little ad hoc, where we just say, okay, this is like version 1 of how we do Ergot over CAN. That kind of stuff. Apparently, Espressif also has CAN. They call it TWI, which is funny because it's not... Oh, yeah, it's like the two-wire automotive interface, which is not quite the same as TWIM on NRF52, which is two-wire interface, but their two-wire interface means I2C. Internet says, yeah. CAN Classic is 8 bytes a frame, CAN-FD is 64 bytes a frame, and then there's new like CAN XL, which is the like newer, nicer thing. Yeah. So, am I planning to support it? No. Am I open to it being supported? Yes. If you want help in how to support it, let me know and I can do that. But I've for all of my like longer range or higher reliability type stuff, I just use RS-45 instead of CAN, because RS-45 transceivers are super cheap and every device has UARTs, so I do that. But that's also because I've never really worked in automotive or in other areas. So yeah, this is the same. That's gonna be my answer for a lot of stuff. Like, I'm gonna support it if I use it or if I like have a customer that uses it. But I'm open to, like, if someone says this is how I would do it, I would say cool, and you get to be the maintainer of that, and we'll merge it into the Ergot repo, and I'll make you a maintainer, and I'm very excited about that. I know I've been pushing Peter. I don't know. It's funny. I always read it Piotr in my head because I had a friend. I knew his name was Peter, but it was spelled in the same way of Piotr. But we had two friends. One Peter spelled Peter, and one spelled Piotr. And so we called one of the guys Peter and one of the guys Piotr. So now it's funny where, like, even though I know it's pronounced Peter every time, I always say Piotr because of those two friends that I had. So sorry, that was an aside. But yeah, I'm talking about Peter because I pushed Peter towards Postcard RPC, and then I started working on Ergot because some of the limitations I think in those conversations with Peter of like, how would I do this, or like how would we extend Postcard RPC, or even stuff like how do we get rid of some of these generics, or how do we make some of the macros in Postcard RPC work with these generics. And so Ergot is splitting that up into more socket-like interfaces, so there's less magic going on. Peter is fine means there's probably a regional pronunciation. I'll have to find a talk by you or something at some point and figure out the correct pronunciation. I have a massive amounts of clients on a custom rack, so that's why I decided on CAN bus rather than RS-45. That's fair. A lot of the cheap transceivers will only go up to like 8 or 32 nodes, and you can go much higher than that, but you have to buy the really expensive like fractional transceivers and stuff like that for getting more. I don't know what CAN bus typically supports for a single net, but yeah, that totally makes sense. Oh yeah, I guess in German too. Yeah, I guess I'm not. The Peters that I was talking about were both Americans, so yeah, I guess it would be Piotr. Interesting. Okay, cool. Didn't mean to pick on your name. But yeah, I'm definitely interested in it. And if you have questions of like, hey, how would I do this, or does Postcard RPC make more sense, or Ergot make sense? Basically, if you want sockets or if you want multiple hops, it's probably going to be Ergot. Like, especially when you start getting out of like the really simple request response stuff, or if you want stuff like where the microcontrollers are symmetric with each other, or even like you have a much more where the microcontroller is more actively asking the PC for stuff, or like initiating requests, you're probably going to want Ergot, because I realized that Postcard RPC is like very painted into that corner of the shape that it supports. But yeah, I drew a couple pictures. It wasn't a bad day. Drawing some pictures. I used CAN for multi-client network in the past, so I liked how that works and implements addressing in hardware and collision detection. Yeah, that's fair. My Erdnus project takes a very opinionated role where you have one central, and it's driving the. It's more like, it's actually not totally unlike how. What's that other automotive, or not automotive, but the industrial one, Modbus. It's not super unlike Modbus in that, or actually I found out Siemens has a UCS protocol too, where basically like one device is in charge of calling on each of the devices. And what I do, this is a technique that I picked up, I think from actually probably Shockburst, like Nordic Shockburst protocol. You have the central, and it's basically calling on all the nodes, and whenever it calls on a node, it will optionally give that node a packet. So if it has a node or a packet for that node, when it calls on that device, it will give it that packet. And then the device has a chance to give back 0 or 1 packets. So if it just says, I have none for you, thank you, I'm done, it just responds back immediately like none. And if it has 1 packet, it will give 1 packet. And if it doesn't respond, it puts a strike on that device, and after the device hasn't responded 3 times, it says, okay, that device is disconnected. And it just like throws away that device's address, and it just regularly polls all the devices on the network, and that way you don't have too much latency. I think it does one step trickier, where if the device has something, it round robins everyone who still has a packet until everyone says, no, I'm out of packets. And then it goes back and does a whole, I don't know. I'd have to look at how I wrote it up, but it works as long as no one's low power and you don't, it's decently low latency and stuff like that, but there's definitely much fancier ways of doing that. CAN also handles collisions. If you only have one device running the bus and it's calling on everyone, you don't have to worry about collisions because everyone's just being called on. I could also do something a bit more like AppleTalk does, because AppleTalk used to run over RS-422. They do a cool thing where they have collision detection, but essentially everyone sends out like a start of frame. Basically, they send out the header of a packet, see if there's collisions. If there were collisions, then both devices back off. If there was no collision, then the device sends the body, which is much larger. But it's nice because it means that most of the time that you have collisions, it's only when the only collision is a header, so you don't waste a lot of time with two devices colliding. It's kind of a nice thing. Yeah. It's fun to sniff a CAN bus on a car. I believe that. Yeah, I've worked on other avionics buses that work a little closer to CAN, and yeah, especially when they're all like broadcasty nodes, it makes sense. But yeah, if you don't have any like synchronization of the bus, then you need some kind of collision detection, and CAN has that built in, which is nice, which RS-45 doesn't really. So yeah, if I was doing like it's not CDMA, it's what it like CSMA, CD or whatever. AppleTalk has a technique for that, and it's very cool. Yeah, you can find the PDF of the book. It's called Inside AppleTalk, and it has a whole one of these pages explains how they do collision detection on it, because they're also using like super cheap RS-42 or 422 transceivers. Okay, well, it's been about half an hour, so that's a bit more than I hoped. I'm going to fill in these pictures some more. If people have questions, again, always feel free to throw it to discussions. I'm super pumped people are showing up to this. It's nice to be able to talk about it, because that keeps me excited, and if I'm talking about it for a week, that's recharging me so I can go write code, because in the last little bit, I got kind of into a slump of, I'm like, there's so much stuff to work on, I don't know what to do next, because there's all stuff that needs to be done, so it's been good talking to people about this. So like I said, if you have an idea of like, hey, I have a project, how would I do that? Throw it into discussions. Keep showing up in chat. I would love to get other people doing stuff and making commits. Oh, is there? Oh yeah, I have this this up. Yeah, and I also have this. This is the other pull request that I'm figuring out lifetimes. Yeah, borrowed lifetimes. Ugh. But the idea behind this is to use Ergot as the interface for a ESP32C6, so you can do Wi-Fi over a network. So let's say you had like an RP2040 and an ESP32C6. You could use the ESP32C6 as a radio and have the RP2040 talk over it. I have some boards that do that. But use Ergot as the protocol between them, and then negotiate and all that stuff that I was talking about with like sessions and stuff like that. You can do like have exclusive hold of the Wi-Fi radio, but also have multiple endpoints so you can control the Wi-Fi session while also getting like the stream of data. It's exactly what ESP hosted does, but I want to do it over Ergot rather than with a protobuf or whatever. So yeah, that's a hint of what that one is, but I've started getting into some tricky lifetimes of that, because that needs something called borrowed sockets, which I haven't talked about yet, but I'm still figuring out how they will work. So, yep, excellent. Good to see everyone. I'll be back online at 10:30 or so tomorrow morning. I hope you all have a wonderful evening, and thanks for chatting and trying stuff out. See you tomorrow.